Alright, this tutorial today is my attempt to introduce the Cisco Discovery Protocol and to see some of the functionalities of the Cisco Discovery Protocol on Cisco devices and neighboring devices. And we're going to do this by using packet tracer, routers and switches and so on. So I'll begin by setting up a very small network. I'm going to set a server, a generic server. And I'm going to have a switch, and the switch is just going to be used as a relay. I'm not going to set up any VLANs in the switch and so on. I'm going to have a router. I'm going to set up also a generic router. I'm also going to put our next router here on this network. So you'll have the neighbor. This router 0 neighbor is router 1. Right? And I'm also going to have two generic switches. Alright. And I'm going to have two PCs at the edge of this network. Right, so let us connect this network with using the various cables. And I want to begin by just putting that this network here was given an IP address that we're going to subnet this IP address of 192.168.1.0. And we're going to subnet this IP address into a /28. Right? So we're going to choose our cables. We're going to have a fast Ethernet onto switch 0, fast Ethernet port. You're going to have the fast Ethernet 1.1 connected to our router, fast Ethernet 0.0. I'm going to use a DCE to DTE cable, so I'm going to use router 0 as the serial interface that has the clock rate, and router 1 has the serial interface that have the DTDN. I'm going to use straight through cables to connect fast Ethernet 0.0 to switch 1. Again, I'm going to configure this set cable to switch 1 back to this PC fast Ethernet port, and we're going to configure interfaces on these devices. I'm also going to have fast Ethernet port 1.0 on the router connected to this switch, fast Ethernet port, and again connected to PC 1, fast Ethernet port. Alright, given that this IP address is 192.168.1, I'm going to subnet this into a /28. We're first going to go over to my text file. I'm going to put my IP address and our slash notation is /28, meaning that is 28 ones. So you're going to check it out in binary. And so that's going to just open up this notepad here, so you're going to see what I'm doing. Alright, so our place values took up 4 because this is 8, 16, 24, and then 4 wants to give us a 28, does give us a magic number. And if you can remember our dotted decimal, or not the dotted decimal, is our place values, which is 128, 64, 32, 16, 8, 4, 2, and 1, our place values. And we can see that this last borrowed bit is in the 16th place, so we know our magic number is 16. Alright, so this magic number means that our networks are going to increment by 16. Right, so let's take a look at what we're going to be working with here. So we have a network here, one network here. We also have a network in between these two routers, and then we have another network here which makes it 2, and another network here that makes it 3. So we will not use 0 as the first network. We're going to start, but let us count out the networks first. Our first network would be 192.168.1.0. Our second network would be 192.168.1.16 because we're going up 16. I like to always have my calculator tool prepared to make sure. Then our other network would be 192.168.1.40.32, my bad. And then 192.168.1.48 because we're going up in 16s, and we could always check it here. 16 plus 16 is 32, and plus 16 is 48. And the other network after that, plus 16, is 64. Alright, we will get 16 networks here nonetheless, but we're going to only be using 3 networks, and we're not using 0 as our first network. So this 16 network would have a broadcast IP of 31. The 32 network would have a broadcast IP at 47. And the third network would have a broadcast IP at 63. So we're going to only be using these 3 networks here basically. So server 0 to this router here would be the 16 networks. So we're going to use this here. I'm going to type this, it will be the 16 network, 192.168.1.16. The network in between the routers would be the 32 network, 192.168.1.32, and this particular network here would be the 48 network, 192.168.1.48, and the network here on this side would be the 64 network, 192.168.1.64. So we have the 64 network on this side, 48 network on this side, and there's a network in between the routers, which is the 32 network, and the network on this side here is the 16 network. Right? Let's do some more housekeeping. So on the 16 network, the server would have the second usable address, which will be 192. In fact, the third usable address, or the second, we could use it as 168.1.18, and its default gateway, which will be the router fast Ethernet address, its default gateway, right? And that will be fast Ethernet 0/0 would be 192.168.1.17. Right, that will be the default gateway on the 16 network. Then the router in between the routers, we're going to have just 2 IP addresses that we're going to use. We could use variable length if we want here, but just for the sake of this tutorial, we just keep with the /28 notation, which means that brings us to a subnet mask, or a net mask I should say, of 255.255.255.240. And how do we get 240? We add the place values. 128, 64, 32, and 16 gives us 240. Right? Then the router serial interface, so that will be R0. The router serial interface here will be 192.168.1.33. And router 1 serial interface, which is the DT end, will be 192.168.1.34. Right? Then the PC will take us up on the 48 network, the second usable host, and its default gateway will get the first usable host. So on the 48 network, the PC will get 192.168.1.50, and its default gateway will be 192.168.1.49, and PC1 will pick up 192.168.1.66, and its default gateway, which will be the router fast Ethernet address, will be 192.168.1.65. Alright, so we mapped up the network, found out what was the magic number. As you can see, the magic number is 16, so the network should increment by 16. Find out which one of the broadcast IPs for each one. Alright, we set the net mask as 255.255.255.240. We got the server address, which is the second usable host, and the router's fast Ethernet default gateway is .17. Router 0 serial interface takes up the first usable address, and router 1 takes up the second usable address. PC 0 takes up the second usable address in the 48 network, while the default gateway takes up the first, and PC 1 does the same.